Good day, everyone. My name is Joyce May Bitaring, and today I'm going to discuss diffraction. What is diffraction? Diffraction is when light waves encounter an obstacle or pass through a narrow opening. The light waves bend around the edges of the obstacle or opening and spread out. This phenomenon is called diffraction. It can be observed with all types of waves involving sound waves, water waves, and electromagnetic waves such as light. Diffraction of light demonstrates the nature of light or the waves-like properties of light. When light waves encounter an obstacle or slit, which is comparable in size to the wavelength of light, the light waves bend around the edges of the obstacle, creating a pattern of alternating and bright regions known as diffraction of light. According to Eugen Fresnel principle, every point on a wavefront acts as a secondary waves. These waves from different parts of the opening interfere and produce the diffraction pattern on the screen. This pattern indicates the light is behaving as a wave interfering constructively at some points and destructively at others. The bright bands are regions of constructive interference, where crests of the waves met the crest of the other waves, which means that the waves are in phase and add together to create a larger wave. For destructive interference to occur, the waves must be out of phase by 180 degrees. This means that the crest of the wave must meet the trough of the other waves. The amount of diffraction depends on the relative size of the wavelength of light to the size of opening. If the size of the opening is much larger than the wavelength of light, the diffraction will be almost unnoticeable. If the opening is comparable in size to the wavelength of light, diffraction will be significant. The smaller the size of aperture or obstacle and the longer the wavelength, the greater will be the diffraction. The greater the size of aperture or obstacle and the shorter the wavelength, the lesser will be the diffraction. Two types of diffraction. First is the Fresnel diffraction. It is when the source or the observer is relatively close to the obstructing surface. This proximity results in complex diffraction patterns. Second, Fraunhofer diffraction. It is when the space and the observer are so far away from the obstructing surface that the outgoing rays can be considered parallel. Fraunhofer diffraction patterns are simpler and easier to calculate mathematically, making them valuable for various applications. And that is all for my discussion, and this will be continued by my co-partners. And see you. That's bye bye.